So we solved equations for pretty much your whole math life, and now we're solving not equations called inequalities. So when two things aren't equal to each other, they're an inequality. So linear inequality is an inequality that contains an algebraic expression of degree 1. So lines have just an x, no x squared, no x3, nothing like that. So to solve a linear inequality, you actually do the exact same thing that you used to do for equations, or you still do for equations. It's linear, right? You don't have to factor anything. You just bring things over and you solve for x. So for instance, I have an inequality here where this line is greater than this line. So this line looks like this. The 8 looks like this. When is the 3x minus 1 greater than 8? So you can do it graphically if you want, or I could just solve. I still like to keep my inequality sign vertical aligned. So 3x must be greater than 9. And now I can divide by 3. So I know that my solution to this inequality is x is greater than 3. This statement is true all the time when x is greater than 3. That's what that means. Yep, it's that easy. Okay, problem that you might encounter when you have a negative sign. So I put a little note here. Careful when multiplying and dividing an inequality by a negative number. So if you can help it, move the negative, like you would in an equation, to the side where it's going to be positive. So that's what I'm going to do at first. So I'm going to say 35 minus 20 is greater than and equal to positive 2x. So I move the 2x to make it positive because I want to avoid this. You don't have to though. I'll show you how not to next. I'm going to collect these. This is 15. Divide by 2. 15 over 2 is greater than or equal to x, or read the other way. X must be less than or equal to 15 over 2. If you want to put this in interval notation, this is negative infinity to 15 over 2. This is set notation. That's interval notation. Okay? You're just stating the interval that this statement is true. In equations, there's one answer. In inequalities, there's an interval. Okay, how do we rock with the negative? No problem. Negative 2x is greater than or equal to 20 minus 35. Easy to get here. But now, when you're dividing by negative 2, anytime you're multiplying or dividing an inequality by a negative number, you must flip the sign. You must flip the sign. So take a look at that sign flip. I divided by a negative 2, so I flip the sign, and the result here is going to be x is less than or equal to 15 over 2, which is the same as that, same answer. So you wouldn't have got that answer if you didn't flip the sign. You would have got the opposite answer. So be careful. Yeah, if you can avoid it, or just go head first into it. Okay, double inequalities is kind of the same thing. It's like an equation, or like when you used to solve like proportions, like sine law. You can do something to all three equations if you want. You can do something to all of these, whatever it is you want. But I don't know what to do to all three of these because I don't know what's going on in the middle here. So I don't really like to decide stuff until everything is simplified. So I'm going to simplify this middle. That's going to be 6x plus 12 minus 2x minus 2. Don't make a mistake there. I'm going to collect my like terms in the middle, like I'm in grade 9. 4x plus 10. And now I'm here. I could divide by 4, but this is not divisible by 4, this is not divisible by 4, this is not divisible by 4. So instead I'm going to subtract 10, because what I'm trying to do is isolate the x. I can't bring the x anywhere. I can't bring the x anywhere because I have a double inequality. It's like this question and this question. So by subtracting 10, I can get 20 is 4x and 36. So all I did here was subtract 10. And now that I've subtracted 10, I have my x kind of as a monomial. I can now divide everything by 4. If I divide this by 4, I get 5. If I divide this by 4, I get x. And if I divide that by 4, I get 9. So this statement up here is true in this interval. Any number between 5 and 9. If I plug in an 8 into x, that's going to be true. If I plug in a 10 into x, that's going to be false. This number in here is probably going to be greater than 46, and that's not what it's saying. Okay, so these are the only number that are going to be solutions in this inequality. Okay, and that's it. Pretty easy section for 4.2.